Okay, this is our next section in lecture in section 2.2. We're going to be talking about the addition of fractions with addition and subtraction of fractions with like denominators. This is the easy one, and this one will go quite quickly. Then we'll have to go have a second little talk before we continue on with subtraction and addition of fractions that have unlike denominators. So first of all, when we say we have like denominators or common denominators, as you see right here, that means that the bottom number, the denominators, are exactly the same. And adding and subtracting fractions with like denominators is done by simply adding or subtracting the numerators and then carrying along the common denominator. And that's because we're simply saying, okay, we have this fractional representation and we have 4 of these pieces, and now I'm going to take one of those pieces away. And you can't tell how many to take away until you have them in the right denominations, and the denominators being those denominations. So that's a short, brief explanation about why we do what we do. So we're going to go ahead and do this by example, showing you exactly what I was stating over there on the other side about what common denominators are and how we add and subtract. So in subtracting 4/5 and 1/5, what I'm going to do is I'm going to be subtracting the numerators, so 4 minus 1, remember subtraction order does matter, and then I'm carrying along that common denominator, and 4 minus 1 is going to be equal to 3, and then those are 3/5, and so we have 3/5 as our final answer. Now 3/5, 3 and 5 are both prime numbers, and therefore we know they can't reduce. So what I was saying pictorially, let me just show you a quick answer here. And so if I had a figure here broken up into into 5 parts, draw the 5th one right there, and then let me erase the other one. When I do the subtraction here, what I would say is, okay, if I started out with this here and this here and this here shaded and this here shaded, so I have 4 and I'm at 4 of 5, and I'm going to take away one of those 5. I take it away just like that, and that ends up with now 3 of the 5 shaded. And so that's all we're talking about when we do subtraction. So now our next example is an addition example, and this one's going to be a little bit more difficult, but not too much. So we're going to do the same exact thing. We're going to add the numerators. We have 23 of these 105 pieces, and we're going to add 4 to that, and we're going to carry along that denominator. And now we see we have 27 105ths. However, we're not done with this problem, because this problem needs to be simplified. Remember our simplifying exercises from earlier in this section. So now we need to remove those common factors. Now I know that these have common factors because 2 plus 7 is 9, and that's divisible by 3, and 1 plus 0 plus 5 is 6, and that's divisible by 3. So I know these things are at least divisible by 3, so I know it can reduce. That's where those divisibility rules that I talked about in a side lecture come in handy. Now I'm going to go ahead and use prime factorization on this. So 27 we know to be 3 times 9, and 9 is 3 times 3. So I'm going to use 3 times 3 times 3 in order to reduce this thing. And then 105, well 105, I know 5 will go into that, so 5 and 5 go into there 21 times, and 21 is 3 times 7, so there's the prime factorization of this one. And now I can use canceling to reduce it, so one of those factors with one of those factors, and I cancel there, and now 3 times 3, which is equal to 9, and that's 9 over 5 times 7, which is 35. And we could have gotten that same way, that same answer, if we would have found the greatest common factor and divided out the greatest common factor from numerator and denominator. So this was the easy one. This is adding and subtracting when the fractions have the same denominator. Now we're going to go and we're going to talk about what happens when we have unlike denominators. But that requires us to first discuss how we're going to how we're going to get the same denominator before we do it.